Here's a review of the osmosis and potato cores part of the last lab. It's good to review this just to practice using the vocabulary and maybe to see in pictures what typical results would look like, and then knowing what those typical results look like, be able to explain why the cores either increased in size or decreased in size, and use the vocabulary hypotonic, isotonic, and hypertonic in those examples. So in that part of the experiment, if a lot of experimental variables in doing a lab like this, but if the cores were cut correctly and accurately, if the salt solutions were mixed correctly, and the cores sat in the various salt solutions for a sufficient amount of time, and then the ending measurements were done accurately. If all those things were true, then the typical results should have been, let's go over this part here and see these results. Here are our four solutions. Cores in 0% solute, that would be distilled water, not tap water. Cores in 1.75% salt, cores in 3.5% salt, and cores in 7% salt solutions. Let's assume that our beginning volumes were what the directions suggested would be what to shoot for. So the beginning volume of each core in each solution was 4,000 cubic millimeters. After the cores sit in these different salt solutions for a number of hours, the typical ending results that are expected are that the cores in the 0% solute would slightly increase in size, that those in the 1.75% salt would slightly decrease in size, the cores in the 3.5% salt would decrease in volume quite a bit, and those in the 7% salt would decrease in volume even more. Now, why is this? Well, the 0% solute solution, distilled water, has no salts or solutes of any kind in it. So it is 100% water. Well, all living cells have some salts in them, some minerals. They have some solutes. Potatoes are no exception. Only if the potatoes had no solutes, no salts in them of any kind, would those potato cores either stay the same or possibly decrease in size a little bit. Now this is tough because that's not much of an increase to be able to measure accurately. But theoretically, the cores in the 0% solute solution should have gotten a little larger. The cores themselves are hypertonic in relation to the environment that they're in, which is the hypotonic distilled water. The cores in the 1.75% salt get a little bit smaller. Now this is hardly noticeable, and sometimes you can do all of these things correctly and you will find that there's really not much of a difference. And so, I mean, certainly in terms of a grade, explaining this one, you weren't graded if you got the right answers necessarily. If you explained what you thought should happen and you used the vocabulary correctly, then the grade was given for that. But just for your own information, theoretically this should have gotten a little smaller. That would mean that the cores are hypotonic in relation to the salt solution that they were in, which is hypertonic. So again, those terms, the cores were hypotonic in relation to the water. That means they had more water inside their cells, more water moved out than moved back in, and there was a net decrease in volume. That was even more pronounced, and the results should have been really obvious in the 3.5% salt. So starting with 4,000 cubic millimeters as a beginning, sitting in 3.5% salt for a while, the ending volume is somewhere around 3,000 or 2,900, 2,800, 2,700 cubic millimeters. A lot of that final number depends on how long they sat in the water. But they would have obviously gotten quite a bit smaller. And the reason for that is that the cores are even more hypotonic in relation to the hypertonic water that they're in. So more water went out than went back in, the cores shrunk. 7% theoretically would be an even stronger concentration gradient from the hypotonic cores, more water moving out into the 7% salt solution than would move back in, and therefore they decrease in size a lot. Now, can we tell from this data what the solute concentration of the potato is? Let's look at a graph I've made. Here's a graph of the data that was just expressed. The vertical axis, the y-axis of the graph, is the average core size in cubic millimeters. The x-axis is the solute concentration in percent. Notice that that x-axis is laid out in pretty much, they're supposed to be even units, not just the units that we did, that we actually had the cups in. So we started with the beginning volume concentration of all the cores was 4,000 cubic millimeters. No matter what concentration of salt was in the cup, we started with cores that were 4,000 cubic millimeters. Now the results, I graphed the results. In zero concentration, the results were, what was it, 4,100 cubic millimeters. The cores were hypotonic in relation to the cores were hypertonic in relation to the hypotonic environment that they were in. So they increased in size a little bit. The cores in the 1.75% solution, the cores in the 3.5% solution, and the cores in the 7% solution all decreased in size. The cores, remember, were hypotonic in relation to the hypertonic environment that they were in. Well, when this is graphed, the point where our results line connecting these dots would cross our beginning volume is the point where the cores are isotonic. So we might not have found any place that was exactly isotonic. We did a 0% salt solution. We did a 1.75% salt solution. They gained a little volume in 0%. They lost a little in 1.75. Where that line crosses is isotonic, and that's about 1%. I think the actual number is about 0.9% solute in potatoes. But I hope that helps. Use the terms hypotonic, hypertonic, and isotonic, and review those results. There are questions, of course, on the midterm about tonicity, and you're going to get them right now.